Hello, welcome to chapter 25 on integration. I hope everyone out there is doing really well during this crazy time. We talked about, hopefully at this point you have done your test and for chapter 24, and now we need to get started on to chapter 25, which is integration. We talked a little bit about this before break. Remember, we said that integration is the opposite or the inverse operation of differentiation. So before, all those big words, we found the derivative of a function. Now we're going to start with the derivative and work backwards to get the original function. Remember, when we took the derivative, we subtracted the exponent. In finding the antiderivative, we will add to find what the original, we'll add to the exponent to find the original function. I'm starting with chapter 25.2. I did leave you some videos on chapter 25.1 on Blackboard, but we do not cover that section in our text. Right now I'm following the handout that is attached in Blackboard to section 25.2. And I'm going to start with, first of all, letting you know what I hope we can do. I hope that by the time we're done, we are able to integrate functions, basic functions. My handwriting is no better than it is on the board. Okay, so I want to review with you finding derivatives. Okay, so derivatives. Recall when we had something like this, y equals x to the third. That was our function, and we were asked to find the derivative. And of course, we could write dy, oh, there goes my pen again, dy dx equals, because dy because the function is in y, and dx is because this part is with respect to x. And the derivative of that was, remember, take the 3 times the coefficient of the 1, so we would get 3x to the 3 minus 1, which was 3x squared. But let's look at this function, y equals x to the third plus 4. Let's take the derivative of that. dy dx would equal, again, 3x to the second plus 0, which is just 3x to the second. Notice we got the same answer that we got in the first one. Let's try a third function. Y equals x to the third minus 7. Let's take the derivative, dy dx, and notice again we get 3x squared. So for each of these three functions, we end up getting the same derivative, 3x squared. Now think about this, because remember, when we do antiderivatives, which is right now, we're going to start with this and work backward to these equations. Note that in all three of these, if we started with the 3x squared and worked backwards, we would get the x cubed for all of them. But our constant would differ. In this first one, the constant would just be plus 0. In this one, it's plus 4. In this one, it's minus 7. So to represent that constant, because we don't know what it is, we use something called the c, or the constant of integration. C equals your constant of integration. That will account for all of these three different cases. So let's get into this and see if we can do some of these problems. Let's start with the power rule for integration. So the power rule for integration, yeah, there has to be a power rule, you know that. The power rule for integration. The good news is there's no product rule or quotient rule. The power rule for integration says that you're going to find the antiderivative, you're going to add and then divide by your new power. Here's an example, and this is on your handout. It says, take the antiderivative, that's the symbol there, it looks like a large S, 6x dx. So notice we're starting with the derivative, and we want to work backwards. So the opposite rule applies. So the first thing you do, one thing that the book doesn't, and it's just an extra step. I don't do it in the future, but I'm going to show you it here. They take the 6 out in front, and then they leave this as the integration of x dx. So the 6 just comes down, and we get, here's how we use our power rule. Our power rule says take whatever your power is on your variable, and it's x to the first, and add 1 to it. Okay, so I would have x to the second, because I added 1 plus 1 is 2. Yay. And then I divide by that new power. Plus, I have to have a constant of integration because I don't know what that would be. It could be any of the constants. So we end up with, if I take the 2 into the 6, I get 3x squared plus c. That is the antiderivative. How do we know if we did it right? Well, start with 3x squared. And let's find the derivative. dy dx would equal what? 6x plus 0, which is exactly what we have over here, 6x dx. Okay, so that's all you do. It's just working backwards. Now, of course, they get a little bit harder each time, but let's try another easy one. Let's find the antiderivative of 4x dx. I'm going to give you a second to try that, just to make sure you can handle it before I go to something harder. And the way that I do these is just to leave the 4 and then work with the variable. So we have x to the 1 plus 1, because it started out as 1, which is 2. So we have to divide by 2, plus the constant of integration. That's going to be what you forget, the plus c. Everyone does. So we would end up with 2 goes into 4, so we'd have 2x squared plus c. And that's it. That's all you do. Can we handle that? Okay, let's try number 3. Find the antiderivative of 5x to the third minus 6x squared plus 1 dx. Okay, and this is just a polynomial. And just like we did the derivative of polynomials, you just took each term and took the derivative. We're going to do the same thing here. We're going to take the antiderivative of each term. So for the first one, I'm going to have 5x to the what? 3 plus 1, or 4, and then divide it by 4. Minus, now let's do this term, 6x to the 2 plus 1 is 3, and then divide by the 3, plus, this is a 1 over here. Remember, this would have to be a 1x, because when you take the derivative of a 1x, you get the 1. And don't forget our ever-present plus c constant of integration. And then you want to simplify if you can. This simplifies to 5x to the 4th over 4 minus 2x to the third plus x plus c. And that is it. So this is the first video on chapter 25.2 on finding the antiderivative.